All right, so welcome to another lesson. This is day 5, and then we are in lesson 2 currently, data on Google Cloud. So lesson 2 in the Preparing Your Professional Machine Learning Engineer series. We shall continue from where we stopped last week. If you're just joining us, please visit our YouTube channel. Just Google the GDG Cloud Uniport, GDG Cloud Port Harcourt, right? You would see our YouTube channel. Okay, so we're going to start from this point straight away. Okay. All right, so data sets can be created from different from we are looking at the TensorFlow API that can be used to create data sets from multiple file formats. All right, so there is an API that help us to TensorFlow that can help us to read data from different formats, multiple formats. So you have the text line data set format, the TF TensorFlow record data set, and the fixed line record data set. So these are a number of file formats that are very essential. So depending on what you want to do, you might start looking at various ways in which to read data. So when building production-ready pipelines in TensorFlow, it's very important you choose the right input format. All right, so that's why the TF data API was designed to handle various formats. And now in the first part, the text line data, what this does, it creates a data set where each element is a single line from one or more text files. So this allows us to read, so let's say we're performing something like sentiment analysis on product review. Sorry, let me go back. So let's say we are performing sentiment analysis on product reviews. All right, and our raw data is very large. Maybe it's a TX file, TXT file, or CSV file, where each row is a review. You know, you have review, and then you have probably we have the label, the sentiment, whether it's positive, negative, or neutral. All right, so, but in this case, we are reading this very large data set. So when we use the text line data sets of this TF data API, right? So what happens is it reads each line and passes it into the processing layer for tokenization. So each layer will be read as a single line, and then to be passed to the processing layer for tokenization straight up. All right, and then the fixed length. Let me explain the fixed. Let me explain the TensorFlow record data set, the TF record data set. All right, so now this is a simple record-oriented binary format. What this means is that it's essentially a sequence of binary strings stored on disks. So for instance, let's say we are training a text-to-image model with billions of samples. Now, instead of the overhead of opening millions of individual JPG images or text files, we might decide to pack them into a large TensorFlow record files. So this is very good to stream data sequentially, which will give us much faster for disk IO operations. So it essentially takes large large files and then pack them into what we call the TF record files. And then if you do that, it will reduce your training bottleneck, especially when you have to deal with the input output wait time, trying to read from disks before it processes the data. So this actually saves a lot of time reading from disks, reduces I/O wait time, right? So beyond the watchout, you might see questions that have to do with I/O waste time, reading large data sets, TensorFlow records. You should start thinking in terms of the TensorFlow record data set. Now, the fixed length record data set. Now, this is used when we have data consisting of fixed binary records. Now, in this case, we're talking about fixed size binary record. So this is, for example, let's say we have an old sensor data, or maybe a scientific telemetry where the reading is exactly 128 bytes of binary or raw binary. We have the data, a sensor that the reading, for us to read it, we just have to read exactly 128 bytes of raw binary. Right? So we have a fixed length of record in this case. Now, this component allows us to do what? It allows us to read these chunks directly without any separator characters. It just allows us to read the 128 bytes as required. And this is very highly efficient for specialized hardware logs. All right, so this is it for now. Remember, we are talking about data on the cloud, and then we are processing data from injection to storage, right? So from the point of data injection, you're considering in the entire data preparation stage and the machine learning workflow, we need robust tools to move data from the source to our training environment. All right, so, and then we have all these services offered by Google Cloud. We have the PubSub, the Dataflow, Dataproc, and the Cloud Data Fusion. So these whole tools allows us to ingest data, process it, store it, analyze it before we use it for machine learning. All right. Now, PubSub. When we talk about PubSub, PubSub is a messaging service, asynchronous. Asynchronous in the sense that it allows us to let's say for instance you go to the restaurant and order food. You can order a food in a restaurant and then sit down. You've ordered the food. You don't have to wait for your order in line. You can go and sit down and be doing other things. And then when your order is ready, it's brought to you at the table. This is an example of asynchronous. Instead of, when you say synchronous, or instead of you staying in line and after the process to finish before you do the next thing. So let's say you're in a bank now and there's a queue, you have to finish the very first person has to be attended to before you be the next, if it's a queue. All right. So, but in this asynchronous messaging system, let's say, for example, you have a mobile app sending click stream of data in real time. So what PubSub will do is to act as a buffer. You're capturing click streams in real time, click streams. But what PubSub will do what? You capture the millions of events per second, and so it shows that you don't have to download. The processing pipeline will not be overwhelmed because of the downloads, because you're trying to process everything in real time. The PubSub will act as a buffer. It will be taking everything in real time, while the processing will be done gradually to not be overwhelmed. So when you have real-time data, you're looking at PubSub, real-time injection of data, you're looking at PubSub. And then data flow. Are we still following? Can you still hear me? Any question at this point?
No, we can hear you.
All right, good. So now data flow is based on Aperture Beam. Data flow provides a fully managed environment for both. This is used for both batch and streaming processing. Remember, this is for real-time streaming. This can be used for batch and streaming. So you could see something extra here. Batch and streaming, you can use data flow. So for instance, now if you need to resize, let's say we need to resize 1 billion images for training and calculate the running average for a sensor data for real-time fraud detection. Data flow will be our choice because it handles a lot. It handles the resource auto scaling. It can scale. All right. So and also good for batch processing and streaming processing. Data flow. Then what is Dataproc? Dataproc is a managed service for running Apache Spark and Hadoop clusters. So whenever you see Apache Spark or Hadoop cluster, it's pointing towards Dataproc. It's suitable. Dataproc is very suitable for that. So it's a managed service for running Apache Spark and Hadoop clusters. All right. So if for instance, if the data engineering team has already written lines of code and Spark on premises, they have a Spark existing code already on Spark. You don't need to write it for data flow. All you just need to do is do a simple lift and shift for those jobs to Dataproc to gain your cloud scalability. All right. So if you have an existing code already written on premise with Spark, you can just move it straight to Dataproc. So that's why it exists just for Apache Spark and Hadoop clusters. Now, moving to the next, cloud data fusion. So this is a fully managed cloud native enterprise data integration service for quickly building and managing data pipelines. It's the cloud data fusion. All right, so it's very good for teams that want to do virtual drag and drop. You know, there's an interface for a drag and drop, and then you can also connect different sources from different data sources like Oracle, SAP, to BigQuery without having to write complex Java or Python code. So you could actually do some drag and drop here. So you can use it to, it's a fully managed cloud enterprise data integration service, all right? And yeah, so allows for easy connectivity between other services. So this is the cloud data fusion. So in summary, PubSub is for streaming injection, right? Data flow is for large scale batch or streaming processing. Dataproc is for Spark based processing. And then, so cloud data fusion, let's say there is for low code, extra load transform, ETL, low code, very low code. That's why you have the drag and drop interface. So when you have a question where you have the team don't have, they are looking for a low code ETL, all right, then you might start looking at data cloud fusion, you know, as what they might be, what they are pointing at. So, but there's been strategy for exam. Let's say, let me give an exam tip here right now. Later on, we're going to dive into questions, and you'll be seeing questions like, the goal is a managed unified pipeline. When you hear unified pipeline, that means they're talking about batch and stream with minimal. If they say with minimal operation, then we know when you see batch and stream, you should just know that they are pointing towards the best option here for each data flow. When you see something that's managed, and when you see that it's unified, you want both batch and stream. All right. Now, if the goal is to migrate existing Spark or have-do job? Which one will it be? Yes. Is someone listening? Hello? I want to make sure I'm not the only one here.
Yes, we are listening.
Okay, so if the goal is to migrate existing Spark or have-do job, which option would it be? That will be data proc. Explanation. That will be data proc, right? Then, if the goal is real-time event injection, then the goal will be what? The goal will be PubSub, because PubSub has to do with real-time what? Injection, data injection, right? Good. Now let's proceed. Any question at this point? Now, for us to collect data, for us to do before processing data, we have to think of the features we need, right? Yeah. So before we start thinking of building a model, or let's say we want to learn from houses or from customers, we need to understand what data do we need to collect to predict house price. Let's say this is problem I want to solve. I want to predict house prices. What type of data do we need? All right. You start thinking of the number of rooms, the historical sale of price, the location, and sometimes you need domain experts to be able to know which of the features you need to do this. All right. So this will now lead us to. So let's say we are working with what to predict house prices. We will now have to collect a number of features. We have to decide to collect the number of features. So for instance, now you can see we have a numerical field, number of rooms. This house price information is put in a dictionary, and then number of rooms 6, number of bedroom 3 is a numerical, and then this is street names categorical, and number of basement in the room -4. When you're looking at -4, you can see there's number of basement in a room -4. Is it right? You see that there's an error there. Well, the goal here is that all this, you can see that this information is being converted to what? Numbers. So before the machine, before we can use the machine learning machine to before we can build the models for the machine to understand these features, we have to convert it to what? Numerical values. They have to be mapped to numerical feature vectors. All right. So, and there are different ways of doing that. So you could see in this image frame, we could have, we could put it turn it to a categorical, do one hot encoding, there should be a mapping of this text to numbers. And there are various ways of doing that. So for the numerical integer, we have our raw integer number 6, right? So for something like street name, we cannot feed string into the model. Instead, it has to be converted. We might have to do a one hot, what we call one hot encoded representation, right? Which might result to a floating point number, all right? And then in cases like this, you might see -1. This might mean a missing value or an error. So this could be transformed into 0, or we can impute another value, which there are ways of handling missing values. We can impute a mean, we can impute the nearest number, or if we have domain experts, we can actually know what is the right thing that should be there. But these are the process that has to go into to make sure your features are clean and that your mapping is being mapped to the numerical feature vectors. Right? Now, this leads us to what is called feature engineering. This brings us to feature engineering. So what exactly is feature engineering? It's not just cleaning data or finding missing values, but rather it's a creative process of what? Finding additional relevant features from raw existing data. All right, so that's what this Professor Andrew Ng would tell us, that yes, he said is what? It's the process of transforming raw data into features that better represent underlying problem to the predictive models. Right? So feature engineering. So you can often get better results with a simple model. But when you have great features, then better representation often beats better than model complexity. So your goal should be your primary goal should be having better features. All right, so that's why feature engineering is important. So you'll be looking at transforming raw data to better features. You might need to do a lot of things to do your feature. Now, what happens? Look at how we do feature engineering here. So first of all, you have to brainstorm on the features. So each column is a feature actually. So what you're looking at coming up with better features. All right. So you might have to have numerical features, categorical features. You might put them into buckets. You might have to cross a number of columns to get another one that's cross. You might have to use embeddings. You might need to use hash values. So first of all, you have to brainstorm and of course explore the data. Look for it for spots. Look for patterns or abnormalities, and then if you have domain knowledge, you can leverage on it. All right. So then you can study other feature engineering problems. First, brainstorming, and then you can do manual feature extraction, automatic feature extraction. These are what you could do, or automatic and manual combined. By the end, you want to have you might have numerical values, categorical values as features. You might have to put them in the buckets. Buckets like age. Let's say you want to have those that are from 18 to 25 years, they can be in one bucket. That's an age range. That's putting them in the bucket. And then you can have 25 to 35, an age range, put them in the bucket. Then cross, you might want to combine features like longitude and latitude. So you can have them as a feature, right? Then embeddings. Embeddings is actually essential for handling large categorical lists. Because you don't want to use one hot encoding for that, because you have a very large sparse matrix. So embeddings can be very good for handling large categorical lists. So it works like a distinct words in a dictionary by mapping them to dense vectors. That's what embeddings. And then the hashed is a technique to handle categories where you don't want the full vocabulary beforehand, because it might be too much to fit in memory. All right, we're still going to explain that later on in the next diagram. We're going to see So now this leads us to, we're not looking at processing, how processing is done. So we have these Keras processing layers. What is it? Traditionally, you would process, you want to use pandas, NumPy, clean your data before feeding it into the model, right? And but now there's another approach called the Keras processing layers. So the Keras processing layer, what it does is, instead of the traditional way of using pandas or NumPy before feeding your data into the model, this Keras processing layer changed this paradigm by treating processing operation. It treats processing operations as what? As layers inside the neural network. So the processing is done as a layer inside the neural network. So what this means is that your raw data goes in and the model handles all transformation logic internally. So whereas traditionally you would use pandas or NumPy to do your processing by yourself, but in neural networks, it just takes in with the Keras processing layer, you could actually take in the raw inputs, and the processing is inside the neural network itself. That means the model handles all transformation logic internally. Now, what's the benefit of using the Keras processing layer? The benefit is this: there's what we call training service queue, right? So there's some scenarios whereby you train a model, clean it, and then maybe in the process of doing that transformation, you may have erroneously put it in a different format other than what it is in the real world. All right. And then so when you're now using the model, it's giving you different results because you couldn't guarantee the exact same transformation logic used during training. So when you want to do inference, you're not using the same transformation logic you use while you are training the model. All right. So when you use this Keras processing layer, you try to do what? Prevent the training service queue. All right. So now the common categories and then another advantage is it makes everything portable because the processing logic is served with the model, right? The model becomes a standalone artifact that accepts raw inputs like strings and unscaled integer directly because the processing logic is built with it. And then so these are the common categories. So we have layers. There are layers for text vectorization. So it does text processing. There are layers for text vectorization that turns raw strings into token indices or dense vectors. All right. So we have the time frequency, inverse document frequency, the TF, IDF, right? It does text vectorization, converts it to the time frequency, inverse document frequency vectors, and which would normally replace the complex external tokenizers. So this is good for tokenization, and it can also be used for numerical normalization. Yes. So in this case, you might want there's a normalization layer that scales inputs to have a mean of 0 and a variance of 1. So this can be used to to process numerical features, normalize them. It can also be used for categorical feature processing. So there are layers that uses one-hot encoding to handle the mapping of strings to integers. All right, so this could be done. The Keras processing layer has that feature. There's a string lookup and there's a categorical encoding, layer that does that. And then it can also be used for image processing. So You might have layers there are layers for resizing and rescaling images, as well as augmenting. There's augmentation layers, right? Yeah, so this could be used for image processing and yeah, and data augmentation. So the Keras processing layer is very effective. So you could use it for text processing, numerical processing, categorical processing, image processing, and augmentation. Right? So now I think we've touched some of these already. So we see, I already mentioned that we have the categorical encoding that uses one hot encoding or multi-hot encoding or count depth to form a count depth representation. Yes, so that's for the categorical encoder. So let's say you have so once you have in this integer indices, right, you might want to have a dense representation. Now, the categorical and this layer, this category encoding layer, what it does is it turns the integer categorical features into one hot. You can do one hot encoding, multi-hot, or count-depth representation. All right, so this is very good for features with small known vocabulary size. We have seen that before. And then it also performs what we call hashing, the hashing trick. So let's say, for instance, we have millions of users or a vocabulary that changes constantly. So maintaining the lookup table will be very memory intensive. You don't want to have a vocabulary that changes very often and then having to have a table to be looking up like the regular mapping you would do with embeddings. So hashing comes into light here. So hashing performs categorical feature hashing. So this is often called a hashing trick. So instead of learning a specific index for every item, what happens here is it deterministically hashes the inputs into fixed number of bins. So that's what happens here. And then we also have the string lookup that turns categorical values. Categorical values could be red, green, blue into an encoded integer representation. All right. And then you have the integer lookup. So what it does, it maps raw integer values to continuous integer indices that could be read by the dense layer. I mean, some of these concepts might not be clear right now, but just have it in mind that there are a framework that does this, right, for you. This does remember, this is the Keras processing layers, right? So there is a feature for converting, integers, categorical values, images, does hashing. In order to do that, you might have to do hashing, you might have to do integer lookup, you might have to do categorical encoding. Just understand that in that simple way first. Now, so look at how the conversion is being done here. This is for numerical number straight up to a vector. This is very simple. For categorical values could be red, green, blue, or male, female, order. All right. So categorical values, we just did one hot encoding. Now see one hot encoding here. We want to represent green, right? So we say red is 0, green is 1, and this is blue is 0. So we are representing the value green. All right. So there's a vocabulary list. If we want to represent red, we might say 100. Want to represent blue, we might say 001. All right. So this is how we're going to represent each of these values. So, but this is the green representation of green here. Now, this is a clear example of buckets, right? So here there's a range, medium size. There's a range of size from medium. There's a size range for large, and there's a size range for extra large. So in these buckets, you can also do one hot encoding on the buckets. So after doing the buckets, we still have a one hot encoding of this. So here we're representing large, right? Then here we can say a good example of crossing. Yes, we can see a good example of crossing. So there's a crossing between red, two features here. You can see there's a feature here. This is another feature, buckets. So we'll be able to cross red and medium, red and large, red and extra large, green, medium, green, large, blue, extra large. You can see the crossing here. So doing this feature engineering, initially this feature never existed, or maybe even this one may not have existed. But looking at the sizes, you derive this, and then you have to even cross this to get this extra feature, this feature engineering. And then you now go ahead and do one hot encoding to represent the features, right? And so this is embedding, where you have a representation in where you have high cardinality, and then the representation is in high in vectors. Any question at this point? Are we following? So in embedding, this is embedding, right? Yeah, I've just explained embedding. So this embedding, we have many categories, right? So, and using one hot encoding here would I mean, you have a sparse matrix because you have a lot of zeros. You cannot, you have many categories. There are several categories. So category 1, category 2, 3, 4, 5, there are so many. And so if we use one hot encoding to present just one category, there'll be a lot of zeros, and then it'll be sparse metric. And the sparse vector will be mostly filled with zeros. So this will be very inefficient. So the solution of embedding is a dense trainable representation. So instead of having 1,000, maybe 10,000 wide vector of zeros, we might now have a 64 wide vector of floating point numbers. All right. So during training, the model learns trainable parameters, that place smaller categories closer together in mathematical space. So that's embedding. And then, yes. And then you now have hashing. So hashing is used for infinite categories. So when you want to maintain a vocabulary list, and then so what happens, it maps input to the fixed number of hash buckets. All right. So this is it. So this is just what feature engineering looks like. Okay. A number of operations that you might do to do feature engineering. All right, now let's jump into the fun parts. Please, we want to start looking at different questions. Please, before now, any question now before I continue, please? Any question? Now, let's see how many questions we can cover. Please, I want everyone to be ready to answer questions. We'll try to explain the concepts as much as we can and know why we're going to choose the question. All right, so sample question 59. Now, what does it say? Developing a custom machine learning TensorFlow classification model. TensorFlow classification model based on tabular data. Your raw data is stored in BigQuery. Your raw data stored in BigQuery contains 100 millions of rows and includes both categorical and numerical features. You need to use the max-min scalar of some numerical features and apply one-hot encoding to some categorical features. Your model would be trained on over multiple epochs. You want to minimize efforts and cost of your solution. What should you do? Please look at the question. If you can answer any of them, just put the answer on the chat, and then you can tell us why. Just write it on the chat, or you can unmute yourself and answer, please. Well, I'm looking at the chat and not, yes.
It should be, I think, C, because use TFX and data flow, and it is calculating a minimum and maximum for scaling, or second export result to cloud storage TFR. I think it should be C, because right.
Okay. Any other suggestion? Yeah, TFX is TFX is it's a pipeline, a very powerful production this thing for production pipeline standard for setting up full data flow pipeline with TensorFlow records, right? So it actually involves significant development effort and management overheads. So look at the keyword here. The keyword here is you want to minimize effort. So once you see minimize effort, anything that would it solve the problem actually, but it's heavyweight for C. C is heavyweight because you have to start setting up the TSFX production pipeline and with data flow for the TFX records, and then before you now feed it into Vertex AI, right? So we're looking at this easiest way to do this, minimize effort, right? So C wouldn't be the best option here because of this minimized effort. Now let's look at option. Does no one want to say something? Now let's look at option A. Option A here is okay. Let's look at the task here is you want to apply minimax scaling, right? You want to be able to take the minimum and the maximum of a feature and then convert it to another value, right? So this is a form of scaling and then apply one-hot encoding. So the key phrase here is minimize effort and cost, right? So we're not looking for the most complex enterprise architecture here. We want a simple, workable solution. Now let's go to option A. Option A, it's Hugging Face to BigQuery, deploying a machine learning model. Deploying a machine learning model to BigQuery just to encode text features is over-engineering and it adds more complexity. So this is why this wouldn't be right, because talking about deploying machine learning to BigQuery just to encode text features is so much engineering. And we've said why it cannot be C, right? The same need. We are looking at minimal effort. Then let's look at option D. Option D is doing one-hot encoding, SQL to one-hot encoding. So doing one-hot encoding for the SK names is risky. Yes, so that would be nice. So the best approach would be B. Now, why B? In B, you're using BigQuery for, you're using BigQuery in B, right? And then you can use BigQuery to scan hundreds of millions of rows instantly, right? And then you can write SQL query to normalize the scalar for your scalar. Yes, you can write SQL for that scalar to scale numerical features. Write SQL for that. Use BigQuery to read the rows, massive rows, and then you now feed the features into Vertex AI for training. Now look at where you now use TensorFlow here. TensorFlow is used for to perform the one-hot encoding. Of course, you know that we've talked about the categorical encoding. Because it has a categorical encoding layer, it has a string lookup layer, as we've already discussed, to handle one-hot encoding. So this is what keeps BigQuery table clean. Yes, so the data is stored in BigQuery, so you don't need to move it to anywhere. It's already in BigQuery. So you can see minimize effort and cost. The data is already in BigQuery. You're writing your SQL to do numerical features. You feed the features into Vertex AI and then allow the TensorFlow to perform one-hot encoding. All right, so the option here is B. Does anyone have objection? Any objection, or do we proceed?
Flipper, one question is, and when we use BigQuery for training, we need to pay repeatedly.
Sorry, come again.
When if training reads from BigQuery, like each epoch, we need to pay repeatedly for this. And in TFX, it is minimal and also it's cost effective.
Yeah, BigQuery is cost effective. Yeah, and it's scalable, right? And I don't think I heard what you said. You want to write it?
Actually, sorry.
Yeah, I don't think I heard what you said actually.
Actually, I'm saying that if we use BigQuery for training, then it use repeatedly payments to run for the trainings. And if we use TFX and data flows, it's also cost effective and minimal and effortless. So
Yes, yes.
we should go for TFX, I think.
B, yeah, we're going for B.
Okay.
Yeah. So the best approach is B. You're using BigQuery strength, you're using TensorFlow strength. You're not moving your data to anywhere. It's still on BigQuery. And you're writing SQL which is native to BigQuery. And yeah, and you're using the power of TensorFlow to do your one-hot encoding. All right.
Oh, okay, Philip.
Good. Now, the next question. You work for a large organization that recently decided to move their ML and data workloads to Google Cloud. The data engineering team has exported the structured data to the cloud storage bucket in Avro format. You need to propose a workflow that performs analytics, creates features, and hosts the features that your model use for online prediction. If you're just still starting out your career in machine learning, it's still okay to listen to these questions. Now, some people study by knowing the questions first, so that when you're not taking the course, you will know that, okay, this is what this does, and this is why this happened. Just listen, just hear the concepts. Right. So now, let's look at this question. Any suggestion to what the answer could be? How would you configure this pipeline? So remember, you're modernizing data stack. All right. Someone said you have structured data setting in cloud storage. You have a structured data sitting in cloud storage. The data is structured already and it's sitting in Avro format. There are two goals here. You want to perform analytics on the data, and then you want to serve features for online prediction. Two things. All right. So which will be your decision? Someone say D. D is what? Ingest Avro files into BigQuery, perform analytics, use BigQuery SQL to create features and store them in a separate why do you say D? Okay, now there are two decision points here. You want to perform analytics on data and online prediction. Analytics, the keyword here is analytics. And do you use BigQuery or Spanner? Do we use BigQuery or Spanner? That's the first thing you need to know, right? So Cloud Spanner is built for Cloud Spanner is built for transactional workload like banking ledgers. It's expensive and not optimized for large-scale analytics. So this rules out A, cannot be A because we want to do analytics on data, right? It's an analytical workload we are talking about here. Now, so the answer must have to do with BigQuery, right? So BigQuery is serverless, cloud serverless data warehouse designed for analytical workloads. Good. So this eliminates option A and option C because they have Cloud Spanner. Good. Now we are left with option B and option D. Now let's see. Now, second, where do we host the features for online serving? That's the next question you should ask. All right. Now let's look at the two options. Do we host it on BigQuery or should we host it on Vertex AI Feature Store? Okay. So now why BigQuery is fast for scanning billions of rows, right? It has high latency for retrieving a single row in real time. Yes. Yeah, so, but it's generally not suitable for online prediction requests. We have milliseconds count. All right, so Vertex AI Feature Store will be what? It's designed to serve machine learning features at scale with low latency. All right, so so our answer will be B. So now you know why it's B, right? Because we're using BigQuery to perform analytics. And then we design a pipeline that creates the features and store it on Vertex AI just for online. So the very good thing is Vertex AI for online prediction and BigQuery for analytics. So use this elimination method in your exam. So when you see Cloud Spanner, you just know that the Cloud Spanner, you want to do analytics on it's an analytical workload. This is transactional. This is transactional. You just remove option A, B, and you're left with these two. Then you don't want to use BigQuery for for online prediction. So you take out this, and the answer is what? Answer is B. Good. Any question at this point? Do we all? Good, good, good. Let's proceed. Now, sample question 84. You need to develop a custom TensorFlow model that will be used for online predictions. The training data is stored in BigQuery. You need to apply instance level data transformation to the data for model training and serving. You want to use the same processing routine during the model training and serving. How should you configure the pre-processing routine? Yes. What do you think is it? If you look at this question is talking about model, is MLOps. It's looking at training 7 skill. What could be the answer? You should develop machine learning model that's used for. So you need to apply instance level transformation to the data for model training and serving. You want to use the same processing routine. So you want to avoid model serving skill. Look at the keyword here. Apply instance level transformation. You want to also use the same routine, right? How do you configure this? So once you see this, you should just start thinking of the best way to avoid model training 7Q. So this question addresses one of the dangerous pitfalls in production and machine learning operations. Yeah, someone said B. Okay. We'll find out. Where any other where else is attempting? Please just feel to attempt. There are no just attempt. Just read it. Attempt. We are all learning. Please. Yeah. So now you're building a custom machine learning, custom TensorFlow model. Remember, the keyword is not just any model, but the TensorFlow model. And you're applying transformations. The transformation could be normalizing numeric feature, or you might want to do one hot encoding, to your instance level data. Now, look at the constraint here. The requirement is explicit. You want to use the same pre-processing routine for both training and serving. If your logic drifts even slightly, what happens? I mean, the prediction will be invalid. So you want to avoid that, right? So now let's look at the various options we have. And see, A says create SQL script to pre-process and write the result to another BigQuery table. Now, if we do this, why should it not be A? If we do pre-processing in BigQuery, very great for training data sets, right? But how do you replicate the SQL logic inside a real-time API endpoint? That's receiving a single JSON object. How do we replicate this? So if we do it in BigQuery, I mean, how can we replicate it in the API endpoint? So it cannot be A. In fact, A will create a skew. So you want to avoid A completely. Now, option C. Let's look at option C. Option C says, write a custom function for serving. Write a custom function for 7, right? Yeah, create a Vertex AI custom prediction routine that calls the pre-processing at 7 time. But it's risky. Because now you have two code bases to maintain. You have your SQL or Pandas code for training, and then you have your Python for serving. All right, so keeping them perfectly synchronized in manual, this is risky. Then because you have two code base here, so create pre-processing function that reads and then create a vector. You have two code base. All right, so now let's look at option. Which option again? Yeah, option B. What's option B saying? Option B, create a pipeline in vectors. Yeah, I read it. Now let's look at this. It's not B either. So create an Apache Beam pipeline. And create an Apache Beam pipeline. And then it's using TensorFlow transform. So here we have, we're doing batch processing during training. We're using a TensorFlow transform on data flow via Apache Beam, right? And to process the data massively, to process the BigQuery data efficiently, yes. Then now the TensorFlow, this TensorFlow transform, what it does is it's processing data from BigQuery, right? But at the same time, it's exporting the logic as a TensorFlow graph. So, and this graph is saved in the model artifacts. All right. So now when you deploy the model with this routine, when you deploy the model, raw data enters the endpoint, flows through these saved graphs to be transformed, and then it hits the model. So this guarantees mathematically identical processing for the training and serving. All right. So whenever you see a question that has to do with training, training, serving, skill, and you want to ensure consistent pre-processing, in the keyword here is TensorFlow environment. Definitely, you're going to be using TensorFlow transform. All right. As long as you're talking about avoiding model training, serving, skill, and then you want a consistent pre-processing in TensorFlow environment, then the answer is just this. TensorFlow transform. Just look for it. Anywhere it is. And surely you get it. Right. So what's the time? Okay. Any question at this point? So the answer here is D. The correct answer is D. If you have any objection, let us know. Okay. All right, let's proceed. Let's see how far we can go before. Okay. So let's look at question 136. 136. 136. You're working on a data set that contains customer transactions. You need to build machine learning models to predict customer purchase behavior. Customer transactions, machine learning, customer purchase behavior. You plan to build a model in BigQuery and export it into cloud storage for online prediction. You notice that the input data contains few categorical features, including product category and payment method. You want to deploy this model as quickly as possible. What should you do? Yes, I need answers on the chat. You want to transform, use the transform clause, which I know some of these things might be scary at this moment. But just make a guess. It can be scary, but we are here to learn. Okay. So now, any suggestions? Any suggestions? Do we continue? Oh, someone said A. Why do you choose A? Okay, so let's look at it together. So the scenario is you want to build you're using BigQuery ML to build on customer transaction data, right? BigQuery ML. So the goal is to train inside BigQuery, then export to cloud storage and save it for online prediction. All right. Now, when you're serving a flow, likely you might use Vertex AI endpoints, right? So how do you want to deploy the model as quickly as possible? You have categorical features, product category, and payment method. Now the challenge here is about portability here, portability. If you manually process the data using SQL before feeding the model, before feeding it into the model, that's for option B. That means your model expects pre-processed inputs. So if you use ML.one hot encoder function on categorical features and select encoder, that means the model will expect pre-processed inputs like vectors, zeros and ones. If you do it directly. So when you deploy this for online prediction, the application must replicate the exact SQL logic to convert maybe credit card information before calling the model. So this is complex and prone to skew. All right, so B will be very prone to skew. And now let's look at option C. Why is it not C? Let's look at C. Now, why BigQuery ML? Right? Why BigQuery ML can automatically handle categorical features? If you just select them using the transform clause. Okay, yeah. So using the transform clause provides explicit control, all right? And so if we use create model statements to create, although you can automatically handle categorical features if you just select them. But using transform clause provide explicit control over pre-processing. So that is why we have one that uses transform clause. So let's look at option A. Option A is option A uses the transform clause. Yeah, the transform clause, as we know, has what we call it has a bundle of processing logic into the model artifact itself. All right, so now when you export the model to cloud storage and deploy it, the endpoint will accept raw input strings, which is credit card information. Remember, I want to process customer transaction. So what you might be processing is your credit card information. And then, so the model handles the encoding internally before making predictions. So the correct approach would be to use transform clause inside the create model statement. All right. Yes. Then inside this clause, we call the ML, the one hot encoder function, right, on the categorical features at model creation. So we still use this create model statement, right? But inside this, we use the transform, create model the statement, then we use the transform clause. Yeah, I mean, this can be scary right now, but whenever you see BigQuery ML, right, and they are looking at exporting for online prediction, look for transform clause. All right, because this is a mechanism that allows BigQuery ML to carry the processing logic with them outside of BigQuery. The transform clause allows the BigQuery ML models to carry their processing logic outside of BigQuery. So when you see transform, because they want to do, you want to store it, and remember, you want to store it in cloud storage, right? Outside of BigQuery. So option A is correct because transform makes encoding automatic. Good. Awesome. Correct. You got it. Ishan. Well done. All right. I don't know whether we should stop here or whether we should maybe we'll take this. What do you say? Should we stop here and then continue next time? We have 1, 2, 3. We have 3 more questions left. Should we continue? Or should we call it a day? We already spent an hour, 30 minutes. Maybe we'll continue next time, right? So that's, let's continue next time. Let's not drag it so long. So thank you very much, everyone. Please, any question at this point, again, before we conclude? So please, if you're just joining this, thank you very much for the class. All right. Thank you, Alexander, for that. I appreciate if you're just joining us, you don't know where to start. First of all, go to thank you, Ayo. Go to GDG Cloud Port Harcourt, gdg.community.dev/GDG Cloud Port Harcourt. Just visit the website, join the event so that you can be getting emails, address, and then so join us. You can RSVP, then join for the sections. So we're having this every Mondays at 6 p.m. West African time, okay? If there'll be a change, you get an email, but it's just by default, we're having every Monday. Then once you've done that, the next thing to do is to go to our YouTube channel if you're just joining us today. YouTube, GDG Cloud Port Harcourt, watch the videos. I have it in the course already. So if you see our courses, you're going to see you have it in a course. So you're going to see everything as a course. So you're going to so you're going to see day 1, day 2, day 3, day 4. I'm going to add day 5 to this. And so we keep building this course. And so you can catch up, right? Hear the concepts, prepare. Then this is to catch up. The real training, remember what we are doing is study group. The main course itself is on Google. So, which is machine learning. Where is it? Cloud skills. Google skills. Yeah, Google skills. Skills at Google skills.google/part 17. This is what we are looking at. Please take note of this, the machine learning engineer parts, and then you start. All right, good. Thank you for sharing that. Please, is anyone happy to share his progress here? I mean, is anyone stuck during the lab? Let's hear your story. So you start the course and then you start, okay? There are a number of, you can start with the tour, start with the, yeah, thank you, Favor. Introduction to AI machine learning, finish this, enter the prepare for data, machine learning, working with, so there's a number of courses, all right? So, but I know by the time you've done this, you must have covered everything we've said in lesson 1. And this will be like lesson 2, right? So there's a lot. You can see feature engineering here. So by the time you reach here, you start making sense to you, all the things we're discussing, right? And then you start seeing why we are using BigQuery. These things will start making sense. You can see things, they'll start talking about BigQuery ML, you know. So these are concepts we already start seeing in the questions. They'll start making sense to you. So you can also come back, go back to the video, watch it again. But trust me, trust is an assurance. If you finish this course and come back to the video, watch them, you can write your certification exam. All right? Yes. Because I just did too. I've written mine. Okay? So you can write your certification exam. Yes. Okay? Yeah, so this is mine. Right? You can do it. I'm just telling you what I did, and let's go through the process. All right? So let's do this together. Okay? So thank you, everyone, for coming, for attending this. I want to see as many as possible. Just, it's a learning journey. You see, we're not rushing this. Normally, this is supposed to be a 6 weeks training, but we cannot cover it in 6 weeks. So we're going to take our time, take this gradually, make sure we exhaust the entire curriculum, and then make sure that as many as possible get the certification. Please, after you come back, when you get the certification, let me know. Tag me, tell your success story, right? So I can keep track of, the efforts we made, and all right. In fact, when you're ready, let me know so that if you're having issues with voucher, I can now say, okay, I can see whether there is opportunity for vouchers, and then see how to, make sure you get that. Okay. So let's keep learning, keep learning. The journey continues. So when we come next time, we'll continue with these questions. We just jump into these questions, complete the questions, talk about future store, talk about the future challenges, then talk about Vertex AI future store, answer these few questions, right. And then if we have time, we'll just look at labs. I know some people will be stopped at some labs. We might go through one or two labs if we have time next week. And then we keep learning, right? I'll stop recording now. Thank you very much, everyone. Stop recording. Yes.